Good morning, 8th grade. Welcome to week 7, day 3. Today is May 6th. So I'm going to take you through what you're responsible for today. We are taking our understanding of elimination and applying it to real world problems. So you're going to click on your classwork tab. You'll go down to day 3. When you click on the lesson, you'll see the steps that we're going to be using for our lesson today. So they're also available in the description. You will click on the lesson. I'm going to use my smartboard version just because it's a little bigger. So I'm sorry about this glare that's happening. It's my light that's in the room. I'll try to be mindful of it. So for the warm-up, you're given a subtraction example. Most of you did pretty well on this. Some of you still were struggling with the keep, change. You were changing the first term, some of you, and then leaving the other two, or you were changing these two but then forgetting about the constant. So be very mindful that when you do subtraction, you keep the entire first equation, you change the minus to a plus, and then every sign in the second equation changes, okay? So that's what's shown here underneath, changing those signs. We get our answer for x. Oh, look at that, there's a mistake here. I'll fix that. So x equals -3. Then we solve for y. We get -5. Oh my gosh, there's mistakes all over this. This should be -3, -5. Okay? Moving on, we're going to be doing the word problems like I said. So I give you like a little chart that kind of goes over the different words that indicate your operations. So there's absolutely always more words than the chart shows. So if more comes up, you can add to it or just be mindful to know what those operations indicators are. Okay? So we're given our first example. It says the Polar Bear Club wants to buy snowshoes and camp stoves. The club will spend $554.50 to buy them at Top Sports and $602 to buy them at Outdoor Explorer before taxes. But Top Sports is farther away. How many of each item does the club intend to buy? And then they give us this chart. So we see that we have two different stores. So I have a feeling that that's going to be what our two equations are about. One's going to be about Top Sports, and one's going to be about Outdoor Explorer, because at both stores, they're planning on buying the same things. And what are those variables that we're looking for? We're looking to see how many snowshoes they're buying and how many camp stoves they're buying at each store. They give us the price per pair of snowshoes, and then they also give us the price per camp stove. So the first thing I would want to do is identify our variables, and I believe that the variables in this equation would be snowshoes and camp stoves, because our question says how many of each item. So that usually indicates like what we're looking for. So over here I'm going to say, all right, I'm going to make X my snowshoes. Okay, and then I'm going to make Y my camp stoves. Okay, so now we need to write our system. So if you look through the lesson, I highlight the important information. We know that at Top Sports, they're going to pay $554.50 for their combination of snowshoes and camp stoves. So let's make an equation about Top Sports. At Top Sports, it's $79.50 per pair of snowshoes. So I'm going to write $79.50 X, because it's $79.50 per snowshoe, okay, plus camp stoves $39.25, so plus $39.25 Y, because camp stoves are my Y, and they tell us at Top Sports they're going to spend $554.50, so equals $554.50. Okay, so there's our equation for Top Sports, and then I'm going to do Outdoor Explorer. So looking at the chart, their snowshoes are $89 per pair, so $89 per pair of snowshoes, plus $39.25 for every camp stove, and in the problem they said they're going to spend $602. Okay, so if we go to our lesson, there's our variables identified like we already did, snowshoes and camp stoves, and then there is our system as well. that we just walked through together. We just came up with this based off the prices that they gave us in the problem, right? Price for each item, and then the total they're spending at each store. So now we're going to solve through elimination. So we want to look to see, do we have the same or opposite coefficients in these equations? And some of you might have already noticed that 3925 is the same coefficient for our y's. So when we have the same, we use subtraction, and that's what we're going to do to eliminate out the y and solve for x. So I'm going to set that up here. So we would have, I'm just going to rewrite my system, 7950x plus 3925y equals 554.50, and then I'll put 89x plus 39.25y equals 602. Okay, so we're going to separate them with our vertical lines. Okay, I'm going to use subtraction because these two are the same. When we have the same, we subtract because that'll equal 0. So when we subtract, we want to remember to use keep, change, change. So I'm going to do term by term. 7950 minus 89. Oops, I forgot my x. Okay, if I use keep, change, change, we're going to get keep 7950. Change to plus, and the 89 becomes negative. Okay, when I combine those together, I would get a negative, look at me, I keep forgetting this x, negative 9.50x. Okay, and then we go to 3925 minus 3925. That we know equals 0, that's why we're doing subtraction to eliminate it. So we get 0 for the y. Bring down your equal sign. Okay, now we do 554.50 minus 602. I'm going to use keep, change, change. So 554.50 stays the same. We now add a negative 602 to that. Okay, and that combination is going to give us negative 47.50. All right, so I went through that a little quickly because I know that we focused on this yesterday, and if you are confused on how to solve with subtraction, please go back to yesterday's video, and I go a little bit slower through the process, but most of you were doing pretty well with it. Like I said, I just noticed some of you still messing up on the KCC step. Okay, so be very mindful of that when solving. Now, we're going to rewrite our equation without that 0. So I have negative 950x equals negative 47.50. And then to solve for x, I'm going to divide by 9.50. Now remember, we made our variables snowshoes and camp stoves. So I should definitely get a whole number here because we're talking about items. It wouldn't make sense to get a decimal. You're not going to pay for a half of a snowshoe, right? So when we divide using reasonability, I should expect to get a whole number, which I do. That answer is 5. Okay, so now we're going to take either one of the equations. I think I take the second one for some reason. So I'm going to rewrite the second equation. 89x plus 3925y equals 602. Okay, I'm going to plug in 5 for x. So I'm going to write 89 times 5. Plus 30, everything else comes down, 3925y equals 602. 89 times 5 is 445 plus 3925y equals 602. I have a feeling I'm going to run out of room. I'm going to subtract 445 from both sides. Okay, this will cancel. I'll get 3925y equals 602 minus 445 gives us 157. And then the last thing we have to do is divide by 3925. So we're going to divide. I'm sorry, I ran out of room. I didn't realize I was going to write so big. Okay. And then again, remember y was representing camp stoves, so we should get a whole number for this quotient, which we do. 157 divided by 3925 is going to give us y equals 4. Okay, so since this was a word problem, we now are going to write our solution like we normally do. So we're going to write solution, and that would be x comma y, so 5 comma 4. But then we have to relate it back to the problem, right? We have to write our sentence. So all this work is shown in the lesson. And then to relate it back, we go to the question, how many of each item does the club intend to buy? We would write, the club intends to buy 5 pairs of snowshoes and 4 camp stoves. Okay? The next is your steps, what was shown to you before. So the only thing we're adding on is identifying your variables, writing the system. All these steps are the same. And then the last step we added on was to relate it back to the problem by writing a sentence. Okay? The next question is very similar to the one we just did. You have 2 different families, the Baxter family and the Farley family. They both are going to the county fair. The Baxter family buys 6 hot dogs and 4 juice drinks for $16.10. The Farley family bought 3 hot dogs and 4 juice drinks for $10.85. We're looking for the price of a hot dog and the price of a juice drink. So for this problem, we would want to say, all right, our X will be the price of a hot dog and the price of a juice drink. Notice how I made them the 2 colors for our variables. And then our system will be, 1 will be about the Baxter family and 1 will be about the Farley family. Okay, so there are our equations. Baxter, 6 hot dogs, 4 drinks, $16.10 total. Farley, 3 hot dogs, 4 drinks, $10.85 total. And then we solve with elimination. So again, you're going to look to see, do I have the same or opposite coefficients? We have the same, right? Our y's are the same. So we would use subtraction. Remember our keep, change, change to eliminate that y. We'll be left with 3x equals 525. I rewrite without that 0. I solve for x. Now, in this one, notice we're getting a decimal, but does it make sense? Let's think back. What was x representing? Well, x was representing the price of a hot dog, and prices can have a decimal because we can use change. So it does make sense that our x is rational, so that's okay, but use that reasonability. Remember what you are solving for, because some of you, when we do our word problems, I think you forget what those variables are representing, and if you keep that in mind, it might help you catch some of those silly mistakes, okay? So then we go on to our next step. We pick one of the equations to solve for y. I use the top one, plug in what you got for x, and we see that y equals 140. We then write that as our solution, 175 comma 140, and then we relate it back to the problem. So the price of a hot dog is $1.75, and the price of a juice drink is $1.40. Now, I'm going to model one more example for you because I feel like the one that you guys have to do today is a little different than what we've been showing you in the lesson. So I just wanted to refresh your memory on a question that is similar to the one you have to complete. I'm going to do one kind of like it, just so that we remember this type of problem. So if I told you that your friends sold 248 candy bars for a fundraiser, Kit Kats were $2 each, and Hershey's were $1.75. If she earned $462.25, how many of each bar did she sell? So you're going to get the graphic organizer that we've used before. So the first thing you want to do is identify your variables. So in this problem, I would say, okay, my variables would be maybe K for Kit Kats. You know, you could use X and Y too. I'm just changing it up to just, you know, remind you can use other variables. And H for Hershey's. Okay, so there's my identifying variables. Then I have to write my system. So in this one, we only are talking about one friend. In our other problems, we had 2 different families. We had, I'm trying to think, 2 different stores, right? But we only have one friend this time. So we have to remember, how can I write this system? Well, one equation could be about the amount of candy bars, and then the other equation could be about the cost. So I know that she sold a total of 248 candy bars, and I know that she sold Kit Kat and Hershey's. So I'm going to write K plus H for a total of 248. right? Some Kit Kats, some Hershey bars for a total of 248. And then my other equation is going to be about the cost. So 2 would be for my Kit Kats, so 2K plus Hershey's were $1.75, 1.75 each equals, and then I'll put my total. So my total was $462.25. Okay, so now I have my system. This is not a great example because I just realized we are not using elimination for this, but this is really just how I wanted to kind of set you up, okay? I wanted you guys to remember that you can write a system where one is about the amount of the items and the other could be about the cost. I'm not going to go further with this because this is not an elimination question. Yours is. The directions clearly indicate use the elimination method for full credit. This is what we are assessing you on. Okay, so please keep that in mind when you are completing your you-do. You are using elimination. You will get a system where the coefficients will be the same, where you can subtract, or they'll be opposite, where you can add. But I'm going to give you a hint. They're going to be the same, so you are going to be using subtraction. Okay, so let me show you where that is so that no one's confused. You'll click on the you-do exit slip. I give you your options, as always, how to complete this. You'll click on it. It'll look something like this. And then you will read the problem, do exactly what I just went over with you, and that is it for today, okay? I hope that was clear. If you have any questions, always feel free to reach out to me through text, private message me on Google Classroom, send me a Pupil Path message, an Instagram message, an email, whatever works for you. Okay, take care.